Hello everyone, welcome to our short lecture today. We're going to study about acid and base. So this short lecture will help you to understand how acid and base actually behave in solution, or what is that particular thing that happened to base in solution. So in solution, acid donate proton and base accept them. When we're talking about proton, what proton it is in question? It is the hydrogen ion, H plus. So if you look over here, when you take hydrogen, we all know, referring to the periodic table, that hydrogen has one electron on its outermost shell. So hydrogen can easily lose that electron to become what we call a proton, H plus, or a hydrogen ion, H plus. So acids are those compounds that are able to donate an hydrogen ion, H plus, in solution, and the base are chemical or compound that actually accept the hydrogen ion in solution. So the BAAD theory help you to remember that base, okay, accept, and acid donate. Okay, base accept and acid donate. So now let's consider HCl and H2O. Okay, HCl and H2O in solution. You dissolve HCl in water. Which one is an acid and which one is the base? Or which one behave as acid and which one behave as base? So even though we know that HCl is hydrochloric acid, it is an acid because it has a particular characteristic when it is actually dissolved in water. So what happens when you dissolve HCl in water? If you look over here, you see that the hydrogen, okay, attached to the atom of chlorine is transferred to the molecule of water, H2O. There is a transfer that happens here. So when HCl transfer the hydrogen atom to the molecule of water, the HCl becomes Cl minus, okay, and H2O will become H3O plus. So you can clearly see that HCl donates the hydrogen to H2O. So HCl is the donor and H2O is the acceptor. So because HCl is donating, it is actually the acid, and because H2O is actually receiving the hydrogen, it is the base. Let's go down here. Now you can see that erase mark that HCl is the acid and H2O is the base. Now, if we reverse this reaction, it is not reversed on the screen now because HCl is a strong acid that dissolve completely in solution. So the arrow is going one way here to show that HCl dissolved in the solution 100%, okay, in solution. Let's assume that this reaction is going in the other direction. So which one will be the acid and which one will be the base here? H3O plus will be given the H plus proton, hydrogen proton, to the chlorine ion to become HCl. So because actually H3O plus is the one donating, if you assume, okay, H3O plus will be the acid because it is the one that is donating, and Cl minus will be the base. Okay, now let's move to the other example here. So in this case, the water molecule is behaving as acid, and NH3 is the base. Okay, if we consider this reaction going other way, consider that this reaction reversible, see that the NH4 plus ammonium ion is actually will actually behave as the acid because it will donate one proton, hydrogen proton, to the OH minus hydronium ion. Okay, so it will behave like the acid, and the OH minus ion here will behave like the base, the acceptor. So way back here we have water as the acid, and actually the NH3 is the base. So what is the other thing we can take away from this slide? Water can behave as acid, and water can also behave as a base, depend on what actually is added to it. Okay, depend on the chemical, the compound that is actually added to water. Water can behave as acid, and water can behave as base. So let's take this quick check quiz. What does water lose when it behaves as an acid, and what does water gain when it behaves as a base? This ends our short presentation about acid and base. So we talk, to summarize, we talk about acid and base, and how they actually behave in a solution. What is that particular characteristic they have, okay, that can help us or help you to know that they are actually acid or they are actually base. Okay, so thank you for your attention.